Hello, everyone. Welcome to our webinar. Our topic today is fire-rated systems in wood construction. My name is Bob Cusick. I am the Eastern Region Manager for APA, the Engineered Wood Association Field Service Division, and I will serve as your moderator for this session today. I will mention that handouts of the slides can be found in the control panel on your screen. To ensure that everyone can hear the webinar clearly, we have muted all participants. While we are bookending the discussion with our cameras on, we will be turning them off during the session to maximize the slide size on your screens. During the presentation, we encourage you to submit questions by typing them into the questions pane on the control panel on your screen. We will try and answer some questions during the program and in the Q&A session at the end of the program as time permits. In the event we're unable to answer your question during the live webinar, your local engineered wood specialist will follow up with you at a later date. Our class today is approved for both AIA and ICC continuing education credits, and a certificate will be provided for all attendees to use for AIA, ICC, or other organizations to self-report continuing education credits. After the conclusion of the webinar, an email will be sent to each attendee. It will include a link where you can get customized certificates of completion for this course. Your feedback is important to us. I would like to point out that you see a QR code on your screen. If you open your camera on your smartphone and point it at your screen, a link will pop up to take you to a survey on this session. We will show you this link at the end of the session or a session today. Our presenter today is Kyle Tilley, an engineered wood specialist for the field service divisions of APA. Kyle is an engineered wood specialist located in the Atlanta area who consults with construction professionals, providing information and recommendations on construction and design. Kyle has a degree in architectural engineering technology from Kennesaw State University and has worked in nearly every aspect of the building industry for more than 25 years. He began his career serving as a certified inspector for the building departments of 2 jurisdictions in the greater Atlanta area, looking at foundations, plumbing, HVAC, and framing. Later working as a top-billed lumber salesman for a lumber supplier in the Atlanta area. Finally, he worked as a site superintendent for 2 major home builders and most recently earned his residential contractor license in the state of Georgia. For those of you just joining us, welcome to APA's webinar on fire-rated systems in wood construction. I will now turn the microphone over to our speaker, Kyle Tilley.
Thanks, Bob, and welcome to everybody participating in this webinar today. First, I'm going to start off with a little background about APA. APA is a nonprofit trade association that is involved in the quality assurance for product promotion for most of the engineered wood products that are manufactured in North America. Originally named the American Plywood Association, APA initially focused on softwood plywood. However, as more engineered wood products came into the marketplace, APA's focus expanded to include oriented strand board, glue laminated beams, I-joist, rim board, laminated veneer lumber, and other types of structural composite products, and became formally known as APA, the Engineered Wood Association, in 1994. APA is made up of 4 primary divisions. The Quality Service Division tests and inspects products during the manufacturing process at member mills. Our Technical Service Division works in product and system research, application, and building code development, and actively helps users and specifiers to better understand and apply these products through our APA Help Desk services. Our Market Communications Division is responsible for communicating APA information, including the development and maintenance of APA publications and our website. The website is www.apawood.org, contains hundreds of APA publications geared to the engineered wood industry. The Field Services Division serves the building industry by providing local in-market support to design professionals, builders, and code officials in the proper use and specification of engineered wood products. All right, let's get started. On the screen, you'll see a copy of the description you were provided upon the registration. During this course, we'll be talking about different assemblies that can be found in APA's Fire-Rated System Design and Construction Guide. This webinar will be a guide on designing and constructing cost-effective and code-compliant fire-rated systems. This is a list of the learning objectives we're going to cover during this course. We'll identify the difference between fireproof and firesafe. We'll look at the key terms related to basic fire protection and identify applicable codes, and with recognizing the test which these systems are measured by the testing agencies. We'll review different building systems that create the required fire protection and describe engineered wood products used today to meet the fire requirements in various buildings. Today's program is for the construction professional who's interested in finding the balance between cost, code, form, and function. Our agenda will follow the learning objectives listed in the previous slide. First, fireproof versus firesafe, along with the codes and terms associated with fire protection. We'll discuss different areas of buildings and how we protect them with these assemblies. We'll talk about considerations when using different engineered wood products. No matter where we live, forests play an important role in our lives. Healthy forests reduce the greenhouse gases in the atmosphere by absorbing carbon dioxide from the air, thus combating climate change. Plus, wood's natural properties combined with the highly efficient wood frame construction systems make it a top choice for builders and those looking at energy conservation. Now, here are a few terms that may be new to you. The first one is critical point at which human life is untenable. The Forest Product Laboratory has done numerous studies on dwelling room fires involving combustible contents. It was concluded that wall and ceiling materials, whether combustible or non-combustible, has little to no effect on the time or temperature to reach this critical point. Flame spread is the spread of fire within a room and is measured by the performance of the materials used for the interior finish on walls, ceilings, and partitions. This is a property of the surface material once a fire has started. Fire resistance is the measure of the containment of the fire within a room or building. It is defined as protection against fire penetration through a wall, floor, or roof, either directly or through a high rate of heat transfer. Protected construction is any wood assembly, such as a floor, ceiling, or wall, with a fire-resistant material added to primary protection for the wood members. This material may be gypsum wallboard, plaster, or acoustical tile. This covering prevents flame passage and the temperature rise while reinforcing framing against collapse. We'll begin with fireproof versus firesafe after having seen the key terms and understanding the important role engineered wood products can provide in many buildings. The first step is recognizing that no buildings are designed nor built that are fireproof. This just does not exist. The photo here is from 1953 fire at the General Motors plant in Livonia, Michigan. The open building design was greater than 34 acres in size and 866 feet wide. This plant was considered completely non-combustible, yet was a total loss due to the collapse of the unprotected metal construction. This fire led to the development of the 204 standard by the National Fire Protection Association. This is still considered one of the worst automotive plant fires in history. And although the type of construction is important, first we have to protect the occupants and firefighters. The presence of a prompt detection using an alarm system or the accessibility of numerous exits are far more vital. The proper construction in conformance with code regulations and the recognition of the protection factors, a fire-safe building can be designed with both combustible and non-combustible materials. Wood and wood structural panel systems have been widely used for both low-rise and medium-rise construction. Next, we'll look at the different codes and testing when talking about fire protection. In order to evaluate fire safety of a structure, building authorities may consider many factors, including flame spread, fire resistance rating. The best known flame spread test is the tunnel test, ASTM E84 or UL 723. In Canada, they have a similar with ULC S102. This test takes a sample of material 20 inches by 24 feet installed as a ceiling of a test chamber and exposed to a gas flame at one end. The rate at which the flame spreads across the sample is compared on a scale. The scale starts at 0 for inorganic reinforced cement board and goes up to 100 for red oak. Additionally, this test will measure the opacity of smoke generated by the burning material. Table 1 in the Fire Rated System Guide summarizes the International Building Code's interior finish classifications. Materials are broken into 3 classes, limited on the area use and based on the severity of the fire hazard. Class A materials are permitted for areas where fire hazards are most severe. Examples of this would be exits in unsprinklered buildings. Class B are permitted in areas of intermittent severity, such as corridors providing egress, and Class C would be other areas. APA trademark panels such as plywood and OSB fall generally in Class B or C. If the panels are fire retardant treated, they can be used in Class A unless prohibited by the code. APA's technical topic, Flame Spread Index. The performance rated wood structural panel publication displays test results based on ASTM E84 or UL 723 showing flame spread indexes for the wood structural panel. This table shows APA performance rated wood structural panels and what class they will fall into based on the performance category. These tests were completed by an accredited independent fire laboratory in 2016 and demonstrated that APA trademark wood structural panels have a flame spread index in the range of 35 to 110 and a smoke developed index in the range of 50 to 175. Now, these include plywood, structural plywood conforming to product standard 1, or for wood structural panels and OSB conforming to product standard 2. These tests again were performed in accordance with ASTM E84. Table 2 shows flame spread requirements for interior finish as called for under the IBC for both sprinklered and unsprinklered buildings. In many cases, ordinary wood frame construction with wood structural panel sheathing provides ample fire safety and is completely acceptable. When unusual circumstances require additional protection, the designer's options include protected construction, mass timber construction, or heavy timber construction. Under each of the building type, you notice type A requires a higher fire rating that allow for larger structures. How do we know how to build these rated assemblies? It can be done by calculation using section 722 of the International Building Code or by tested assemblies. When testing an assembly, it's simply constructed and tested in accordance with ASTM E19, and the rating is determined by the duration of the test. The test is performed using a standard time temperature curve shown on the left here. This allows for a standardized test over a variety of products and construction methods. I should point out that the time temperature curve shown does represent a very aggressive fire. Real-world fire curves will vary depending on the fuel load and other factors unless that what it is shown, but this curve serves as a purpose for standardizing the test. The table shown here shows allowable stories from the 2021 IBC Table 504.4. We've selected to show only the residential aspect, which applies to all building types. Today, we'll be focusing on the fire protection methods used most in Types 3 and Type 5 structures. Some of the more popular protection methods are listed on this slide, and we'll talk about mass timber construction, heavy timber construction, fire retardant treated wood, fire retardant paints, sprinklers, and then we'll go into some detail on the fire rated assemblies themselves. Mass timber construction provides the fire protection by using mass timber, which is defined in IBC by structural elements in Type 4 construction, primarily of solid, panelized, or engineered wood products that meet minimum cross-section dimensions of Type 4 construction. Cross-laminated timber, or CLT, in compliance with ANSI APA PRG 320, is required for types of Type 4, Type 4A, Type 4B, Type 4C construction, provided that the fire resistance rating of the mass timber meet the fire resistance rating requirements of the IBC based on either fire resistance rating of the non-combustible protection, the mass timber, or a combination of both. Section 602.4 through Section 602.4.3 of the 2021 IBC should be referenced for more details. The IBC places limitations on the height and area of buildings according to its compliance with certain established criteria, which are based on the codes concerned with health and safety of the occupants. Because light frame construction is usually the best choice from the standpoint of cost and simplicity, yet it is accorded the lowest basic allowable areas, it is to the designer's advantage to find ways to secure area increases to take advantage of the economic and versatility of wood construction. Type 4 buildings have been approved for up to 18 stories using mass timber. More detail than we're going to go into about mass timber today can be accessed through Woodworks. The use of mass timber for taller buildings has been used in Europe and Canada for some time now, and the intersection of lower embodied energy and renewable resources propels mass timber industry forward. As noted, timber buildings store carbon in the structure for the entire life of the building. Mass timber, for example, has negative carbon footprint equaling to 2,300 cars being taken off the road per year. And this is per the contractor on this Ascent building. The contractor also spoke about the benefits by saying mass timber materials are not inexpensive. However, mass timber offers several cost competitive advantages and long-term benefits. Columns, beams, and panels on average weigh 1/5 the weight of concrete and steel, thus reducing shipping costs and requiring a smaller workforce to install. With prefabricated panels delivered directly to the job site, construction time can be reduced by approximately 25%, saving owners even more time and money. Furthermore, wood structures have been biophilic effect on people, increasing the occupancy's overall health and wellness and give long-term value to the design. Heavy timber construction implies protection provided by the mass wood members. The name comes from early New England textile mills, where it is known as mill construction or planking timber or slow burning. This construction method that while it provides the outside may char during a fire, the surface char acts as insulation, while the strength of the wood is such that it continues to support the load, so the chance of the building collapse is greatly diminished. The minimum dimension required by the code for heavy timber is found in Table 2304.11 of the 2021 IBC and shown in this publication in Table 4. Per the 2021 IBC Section 803.3, there's a heavy timber exemption which states that exposed portions of building elements complying with the requirements for building of heavy timber construction in Section 602.4 or Section 2304.11 shall not be subject to interior finish requirements except in interior exit stairways, interior exit ramps, or exit passageways. Here's a portion of the aforementioned Table 4 showing minimum sizes for mass timber products such as solid sawn lumber, glue laminated timber, cross laminated timber, or structural composite lumber. Now, glue lam beams need a special mention due to their versatility and popularity. We've moved glue lam up in this presentation from where it is in the fire rated systems because glue lam has a reputation for being used in striking applications such as vaulted ceilings and other designs with soaring open spaces. The glue lam has a classic natural wood appearance that hold a timeless appeal, which make it a part of any biophilical design. Aesthetics aside, there are many applications where the strength and durability of glue lam beams make them an ideal structural choice. A glue lam with a minimum width of 5 1/8 inch can be adopted for a 1-hour fire rating in accordance with procedures by the IBC Table 5. This details the minimum depth required for the beam to meet a 1 hour rating based on the width. Glue lambs with minimum widths of 6 3/4 and 8 3/4 can be adapted for 100% of the design load. Tension laminations of the glue lamb beams are always positioned as the outermost laminations of the beam, subjected to the maximum tension stresses in a fire. The outermost fibers of the wood are the first one to be damaged. For this reason, when a rating is required for a glue lamb beam, the specifier should note that additional tension laminations should be used in place of core laminations, and it should be marked on the glue lamb beam rated for 1 hour or rated for 2 hour. You can reference APA's calculating fire resistance of glue lamb beams and columns for more information. The structural member's fire resistance is measured by the time it can support its design during a fire. An exposed beam or column sized for a minimum 1 hour fire resistance will support its full design load for at least 1 hour during a standard fire test conditions which simulate an actual fire. Like mass and heavy timbers, the charring of a glue lamb surfaces during a fire places a premium on the cross-sectional area. Charring weakens the glue lamb's cross-sectional area slowly because of the self-insulation character of the char. Here you'll see different laminations based on the fire rating that is required. Note the laminations in red. The fire rating and fire exposure and balancing of the beam will determine the location and number of additional laminations. The upper laminations shown have the top of the beam not exposed to a fire, and the layups shown below have the upper and lower sides exposed to a fire, where additional outer members will be added to both the top and bottom of the beam. FRT wood is pressure impregnated with chemicals or water solution or other means during the manufacture to inhibit combustion. This qualifies it for a lower flame spread or smoke generation ratings, and it reduces its fire hazard classifications when it's identified as such by a code-recognized testing agency label. It is recognized on parity with non-combustible constructions by many insurance rating bureaus, but not by the building codes. The span ratings and load capabilities for APA trademark plywood are based on untreated panels and may not apply following the fire retardant treatment. Should obtain structural performance characteristics and use recommendations from the FRT plywood from the company providing the treatment and redrying service. I'd also like to point out that products treated with non-pressure impregnated process does not translate into being a fire retardant treated wood, as section 2302.2 of the IBC also requires that an ASTM E84 or UL 723 test shall be continued for 20 additional minutes, and the fire shall not progress more than 10 feet. Fire retardant paints can be used on plywood for non-structural interior finish applications to reduce flame spread ratings, depending on the paint selected. These paints are tested per ASTM E84 or UL 723 for 10 minutes, as compared to the 30 minutes for FRT plywood. The FRT plywood does require additional 20 minutes of testing to comply with the American Wood Protection Agency standard U1. Sprinklers are another option to improve the fire performance of floor ceiling assemblies. With sprinkler protection, the code requirements for flame spread and flame resistance ratings can be relaxed. It may be possible to add another story or increase the building area. Reduced insurance premiums for buildings and contents mean that sprinklers generally will pay for themselves in a few years, depending on the value of the building and its contents. We're going to review a few fire-rated assemblies in just a few slides. All buildings must be code compliant to a maximum permissible heights and floor areas. These specifications are based on certain characteristics of the buildings, including fire zone, the type of occupancy, construction and material systems, the setbacks from property lines, exits, and automatic extinguishing systems. The IBC permits determination of 1 hour fire rated wood frame floors, roofs, and load bearing and non-load bearing walls by calculation. As an alternate to assemblies, 1 hour fire rated assembly can be determined by combining the individual component times of the assembly in accordance with the method and limitations in the code, thereby providing additional choices for the designer. Now we'll look at some examples of how we can protect the different areas of a building. Many of these assemblies are going to look similar, but there are subtle differences that need to be followed, and how you select an assembly for your project will likely be based on cost and needs. Figure 2A shows a 1 hour combustible wall assembly exposed to fire on both faces that has code approved APA rated siding or other approved exterior finish over a minimum 5/8 type X gypsum wallboard sheathing on the exterior side, with 5/8 type X gypsum wallboard on the interior face. Minimum 2x4 studs are required, can be spaced at 16 or 24 inches on center, and a mineral wool or fiberglass batt insulation is used for the wall cavity space. Here's an example that shows a fire resistance directory, which is design number U356. It has a code approved APA rated siding or other approved exterior finish over a minimum 7/16 APA rated sheathing with exposure 1, which can be either plywood or OSB. The sheathing is attached with 6D cement coated box nails spaced at 6 inches on center on the perimeter of the panels and 12 inches along the intermediate studs. Panels can be installed with the long dimension of the panel parallel or perpendicular to the studs. The vertical joints should be centered on the studs. Horizontal joints need to be backed with a nominal 2x4 blocking. A change in these details may affect the fire resistance of the assembly. A hidden advantage when we're using wood structural panels in these exterior wall assemblies will be able to use these products as a nail-based sheathing. Continuous plywood or OSB sheathing is a secure, code-compliant nail base that provides an easy and effective solution for attaching all claddings. We're going to look at some of the advantages that plywood or OSB wood structural panels provide when they're used as a nail base. Stud spacing of 24 inches on center can be maintained with cladding materials that require less than 24 inches on center. Shorter fasteners can also be used because they don't have to be embedded into the framing members. Properly installed wood structural panels provide lateral stability, allowing the structure to resist high winds. And lightweight siding materials can be attached directly to the wood structural panels, providing a structural nail base. Many floor sealing or roof sealing systems are listed in the UL Fire Resistance Directory and are accepted as rated constructions by the building codes. Examples shown in figures 4.1, 4.2, and 4.3 are using solid sawn lumber joists. When looking at the next few slides, you'll see similarities. We just want to point out that depending on your need, wood frame construction will allow for the most flexibility. Basic assembly for the floor system requires a minimum 2x10 dimension lumber, spaced at 16 inches on center with a subfloor sheathing of 1-inch subfloor nominal board, a layer of asbestos paper weighing not less than 14 pounds per 100 square feet, and a layer of 1-inch tongue and groove finished flooring. Ceiling consists of 1 layer of 1/2-inch type X gypsum wallboard nailed to the joist with 5D cooler or wallboard nails. All the floor sealing and roof sealing assemblies detailed in the fire rated design guide require the face layer finish joints to be covered with tape and coated with a joint compound. Screw heads must also be covered with a joint compound. Other subfloor options for this example are listed in the design guide. Figure 4.2 floor system requires minimum 2x10 dimension lumber. The subfloor is a nominal 1-inch tongue and groove boards or a 15/32 wood structural panel with exterior glue. Finished floor requires a floor topping mixture bearing a UL classification with marking as a fire resistance. Ceiling consists of one layer of 1/2 inch Type X gypsum wallboard nailed to the joist with 5D cooler or wallboard nails at 6 inches on center. End joints of wallboards to be centered on the joist. The floor system requires a minimum of 2x10 dimension lumber at 24 inches on center. The sheets shall be installed with their long edge perpendicular to the joist, with the ends centered over the center of the top flange of the joist. Floor sheathing must be installed per the code requirements. Ceiling consists of 2 layers of 5/8 Type X gypsum wallboard, with the base layer installed with the long dimension parallel to the joist, attached with 1¼ inch Type S or Type W drywall screws at 24 inches on center. The face layer gets also installed parallel to the joist, attached to the joist through the base layer using 1 7/8 Type S or Type W drywall screws spaced at 12 inches on center at the joints and intermediate joists. Before we move to the next part of our fire rated systems guide, a little information about I-Joist. Figures 5.1 through figure 6 are applicable to prefabricated wood I-joist, other floor ceiling or roof ceiling systems, which are also recognized in the evaluation reports issued to individual manufacturers or trade associations. These will demonstrate the flexibility that is afforded when building with wood. The efficient use of wood fiber creates a joist that not only contains 36% less wood than dimension lumber with 2x10s and 2x12s, but it's stiffer and stronger as well. I-Joist and other engineered wood products make optimum use of the resource by putting high strength wood only where it's most needed. Another advantage of wood I-Joist is the flange width. The flange width is often wider than the nominal lumber, so it provides a larger target for fasteners to hit when floor sheathing or roof sheathing is installed. These lighter weight joists also come in longer lengths, so that handling is easier with the possibility of running a single I-joist from the front wall to the rear wall of a building. I-joists are typically manufactured in 4 common depths: 9.5, 11 7/8, 14 inch, and 16 inch. Some manufacturers may also produce other depths. All APA I-joists meet PRI 400, the performance standard, at a minimum. Many I-joist manufacturers make products that exceed the minimum PRI 400 and have their own product reports issued through either APA or ICC. As we move through these figures 5.1 through 5.9, varying flange width and flange areas will be mentioned for the different fire rated systems shown and should be accounted for during design and construction phases. Figure 5.1 states that furring channels are installed perpendicular to the joist with 5/8 inch single layer Type C gypsum wallboard installed parallel to the joist. The minimum I-joist size here is 9¼ inches with a maximum spacing of 24 inches on center for figures 5.1 through 5.9. It should be noted the flange thickness and the required flange areas do vary in the next few slides. The minimum flange thickness shown here is 1.5 inches, and the flange area is at least 5¼ inches with a minimum web thickness of 3/8 of an inch. A minimum 1 1/2 inch mineral wool insulation batts are installed adjacent to the bottom flange of the I-joist and supported by the furring channels. Ends of the batts shall be centered over the furring channels. The floor ceiling assembly requires 23 32 tongue and groove wood structural panels to be installed with a construction adhesive applied to the top of a joist prior to the floor panels being installed. Figure 5.2 has several of the same details from figure 5.1 with some notable exceptions, which include resilient channels are used instead of furring strips. Gypsum wallboard attachment differs with a 1 inch Type S drywall screws spaced at 12 inches on center on intermediate joists and 8 inches on center on the end joints, maintaining a 3/4 inch spacing from the ends and edges of the wallboards. It's an important detail, has the 9¼ inch I-joist web thickness here increasing to 7/16 of an inch, with a minimum flange thickness of 1.5 inches, and the flange area is at least 5¼ square inches. Figure 5.3 includes 1x4 furring strips attached to the bottom of the I-joist flange. This increases the mineral wool batts to 2 inches, and they are installed adjacent to the bottom of the flange. A smaller flange can be used with a minimum flange thickness of 1 5/16, and a flange area reduces to 2¼ inches by using the 1x4 furring strips. The minimum 9¼ inch web thickness is again 3/8 of an inch. A single layer of Type C gypsum wallboard requires a tighter nailing pattern of 7 inches on center with 1 1/8 inch Type S drywall screws. Figure 5.4 has floor sheathing installed with a minimum 23/32 tongue and groove wood structural panel. A 1-inch mineral wool insulation is installed below the flange, with the insulation width being equal to the on-center spacing of the I-joist. The 9 1/4 minimum I-joist with minimum flange thickness of 1.5 inches, and the flange area here is 3.5 cubic inches. This single layer gypsum wallboard is required to be a 1/2 inch minimum Type C fastened to furring channels with a minimum 1 inch Type S drywall screws spaced at 12 inches on center on the intermediate joist and 6 inches on center at the perimeter of the wallboard, still maintaining 3/4 inch of a spacing from the wallboard ends and edges. Furring channels are a minimum 0.5 millimeter hat-shaped galvanized steel channels attached perpendicular to the bottom flange of the I-joist, with sealing support clips at each intersection of the I-joist. The clips are nailed to the side of the bottom of the flange with an 1¼ inch long 11 gauge nail. Channels are spaced a maximum of 24 inches on center and are doubled at each wallboard end joint and extend to the next joist beyond each joist. At channel splices, adjacent pieces are overlapped a minimum of 6 inches and tied with a double strand of 18 gauge galvanized steel wire. The furring channels are located at each end of the wallboard, and they must be spaced 2 1/4 inches from the end joint. Figure 5.5 shows us the first double layer of 1/2 inch Type C gypsum wallboard on an I-joist floor system. The 9 1/4 inch minimum I-joist remain at 24 inches on center, even with the second layer of gypsum wallboard is added. The minimum flange thickness is 1.5 inches, and each flange area must be 2 1/4 square inches. 2 layers of 1/2 inch Type C gypsum wallboard installed with the base layer in the long direction perpendicular to the joist, attached to the bottom flange of the joist using 1 inch Type S drywall screws at 12 inches on center. The end joints of the wallboard must be centered on the bottom flange of the joist and must be staggered. The face layer is installed with the long dimension perpendicular to the joist length and attached to the bottom flange of the joist through the base layer using 1 5/8 Type S drywall screws spaced at 12 inches on center on intermediate joist and 8 inches on center at end joints. The longitudinal joints of this layer must be offset 24 inches from those of the base layer, and end joints must be centered on the bottom flange of the I-joist and offset a minimum of 48 inches from those of the base layer. Additionally, base layer end joints are attached to the base layer with 1.5 inch Type G drywall screws at 8 inches on center with a 4 inch stagger placed at 6 inches on either side of the joint. Figure 5.6 details resilient channels installed perpendicular to I-joist and spaced 16 inches on center when I-joists are spaced at 24 inches on center, and changed to 24 inches on center spacing for the channels if the I-joist spacing is reduced to 16 inches on center. 1/2 inch Type X gypsum wallboard with 2 layers is installed perpendicular to the resistant channels. Drywall fastener size and spacing vary in these few slides, so we're not going to detail them on every slide. Figures 5.7 and 5.7a detail glass fiber fiberglass insulation installed between the I-joist and supported by resilient channels. 2 layers of 1/2 inch Type X gypsum wallboard with the base layer installed perpendicular to the resilient channels, and the face layer is longitudinally offset 24 inches from the base layer. 2 layers of 5/8 Type X gypsum wallboard with the base layer installed perpendicular to the resilient channels, and the face layer is longitudinally again offset 24 inches from the base layer for figure, just like figure 5.7a. Figure 5.8 details 2 layers of 1/2 inch Type X gypsum wallboard with the base layer installed with 1 5/8 Type S drywall screws at 12 inches on center. The base layer wallboard is installed perpendicular to the I-joist with the ends of the wallboard attached to the I-joist bottom flange and must be staggered to the equivalent of 2 joist facings with adjacent sheets. The face layer installed perpendicular to the I-joist with the same offset requirements of 24 inches on center. Figure 5.8a has 2 layers of 5/8 Type X gypsum wallboard with the base layer installed with an 1 1/4 Type S drywall screws at 12 inches on center. The base layer wallboard is installed perpendicular to the I-joist with the ends of the wallboard attached to the bottom flange and must be staggered to the equivalent of 2 joist facings with adjacent sheets. The face layer is again perpendicular to the I-joist with the same offset requirements. Figure 5.9 details a single layer of 3/4 inch Type X gypsum wallboard with a minimum weight of 3 pounds per cubic foot in compliance with ASTM 1396 and is attached with a 1/2 millimeter galvanized resilient channels, which are attached perpendicular to the bottom flange of the I-joist with 1 1/4 Type W drywall screws. Channels are spaced a minimum of 16 inches on center. They are doubled at each wallboard end joint and extend to the next joist beyond each joint. A 2-hour assembly with 3 layers of gypsum wallboard has the base layer attached to the bottom flange using 1 5/8 Type S drywall screws at 12 inches on center. The end joints of the wallboard must be centered on the bottom of the flange. The middle layer is attached to the furring strips using 1 inch Type S drywall screws at 12 inches on center with the long dimension perpendicular to the furring channels. End joints must be staggered from the end joints of adjacent sheets and end joints on the face layer. The face layer is attached to the furring channels through the middle layer using 1 5/8 Type S drywall screws spaced at 8 inches on center with the long dimension perpendicular to the furring channels, and end joints must be staggered from the end joints of adjacent sheets and staggered from the end joints of the middle layer. The edge joints must be offset 24 inches from those of the middle layer. Insulation is 3.5 inch unfaced fiberglass insulation, friction fitted between the I-joist and supported by stay wires at 12 inches on center along the top of the I-joist bottom flange. APA's data file, Rim Board and Fire Rated Assemblies, is another publication where detailed information can be found on fire rated assemblies. The Fire Rated Assemblies Design Guide details one of the 6 fire rated rim board assemblies shown in the data file. We're going to review all the ones listed in the rim board data file, and also we'll see the end wall assemblies shown, the I-joist floor systems installed perpendicular to the rim board, as we see on the left, or installed parallel to the rim board, as we see on the right. The 5/8 Type X gypsum or regular 5/8 gypsum wall board shown in the ceiling is to protect the rim board only. It does not necessarily cause the floor assembly to be rated. APA performance rated manufacturers are manufactured and tested under the requirements of ANSI APA PRR 410 or 401. The barrier of continuous rim board on the wall and parallel with the floor joist, or as continuous on the wall along the top of the wall and perpendicular to the I-joist, will meet these requirements. Because the flammability and ignitability of the adhesive used in the rim board is less than that of the wood, the adhesive does not melt prior to ignition. The wood itself determines the flammability of the rim board. These examples show a single wall configuration with rim board thickness variations detailed and gypsum wall requirements with accompanying tables. In the rim board data file, one example is figure 7 shown here. This is a double wall assembly configured to transfer the load to the base assembly with APA rim board meeting the fire resistance rating listed in accordance with ASTM E19. Here's an example from the rim board data file, a double wall assembly which transfers the load to the base assembly with the APA rim board. The gypsum wall board details listed in the accompanying data files show different systems to achieve 1 hour and 2 hour fire ratings for the ceiling membranes. And here's one of those accompanying tables from the data file which show different rim board thicknesses and protection required for each assembly in the double wall configuration with load transfer to the base assembly. This table lists the rim board thickness in the left-hand column, the rim board protection in the next column, ceiling membrane requirements for 1 and 2 hour ratings along with minimum stud sizes. If no ceiling membrane protection for the 1 hour rating is provided for the rim board, it shall be protected as stated in the double wall configuration table shown here. When there's a ceiling membrane protection, the rim board does not need protection. Footnote 1 states rim assembly will transfer the load from either side if the adjacent rim board is exposed to fire and fails. Also, footnote 6 allows for type X wall board may be substituted for type C or regular gypsum wall boards. We should also note APA performance rated rim boards can be manufactured using plywood, oriented strand board, glue laminated timber, or structural composite lumber, which is composed of laminated veneer lumber or oriented strand board. Each one of the fire resistance rated rim board assemblies in the data file have an accompanying table that we just looked at. Here, RB5 is an example of double walls with no load transfer to the base assembly. And the last in this data file shows another double wall assembly with gypsum wall board actually located between the APA rim boards on each wall. We've looked at different assemblies for floor ceilings, roof ceilings, and even rim boards. So how can these be incorporated into your designs? The IBC allow wood frame building to be increases when 1 hour fire resistance is provided for all structural elements in the building. This includes beams, columns, floors, walls, and roofs. Another provision that allows for building areas to be increased is when automatic sprinkler is installed throughout the building. Under the IBC, a 300% increase is permitted for one-story buildings, a 200% for multi-story buildings. An additional benefit is the likelihood of substantial lower insurance rated with sprinklers. Sprinkler systems can also be connected to a central alarm system for additional protection. Basic area increases are allowed if there are large open areas on 2 or more sides of a building. 175% increase is allowed if all sides face towards public streets. Next is unlimited area. The IBC provides for construction of unlimited areas for industrial storage or business uses. Generally, there must be large areas of open spaces surrounding the building, and the building must be completely sprinklered. Finally, firewalls. The equivalent effect of area increases can be achieved by the introduction of properly constructed firewalls. In effect, 2 contiguous buildings are erected when they are separated by a firewall or partition with all openings protected. That brings us back to our agenda. We've learned that there's no such thing as fireproof. We've had a discussion of the codes and terms that are important when learning about fire protection. We looked at how we can address the different building areas and what, if any, special consideration when using engineered wood products. Then moved considerations when designing for wood construction. We've covered many details in several fire-rated assemblies. In reviewing the building size or determining space needed, many engineered wood products discussed today can help meet those needs and potentially lead to cost savings. This concludes our presentation. I'll now turn the mic back over to Bob and see if we've received any questions.
Thank you, Kyle. Yeah, that was a lot of information. We did get a couple of questions. I'm going to turn my camera off. I'd also like to remind people we have put our QR code back up on the screen and remind you that our feedback on today's webinar is important to APA. Your feedback counts. So this QR code shown on the screen will link you to today's survey. Just open your camera on your smartphone and a link will take you to the surveying. So take a minute, fill that out, and let us know how things went for you. But we do have a couple of questions, Kyle. We did have a question on I-Joist. When you got into those assemblies, we use many I-joists, many possible I-joists are out there on the market. And the question was, in the floor assemblies, can you use any I-joists, or are there only certain series that can be used in the assemblies that you showed us here today?
Well, I know we looked at a lot of different assemblies and I-joist. There's a lot of details, and each job is going to be different. So I would say that refer back to our publication, Fire Rated Systems, and that way we can see what the minimum requirements are for each one of these assemblies, and then you can go up in size on I-joist. So just make sure that the web thickness and the flange areas meet the minimum requirements, and then you should be able to use a different series if you need to meet span requirements or different requirements that may be needed for the building. But you can refer back to this publication to make sure the minimums are being met.
Okay, thank you, Kyle. It was noted in these assemblies that you were showing everybody, you mentioned two types of gypsum. You mentioned type X and type C drywall. Can you explain what the differences are between type X and type C?
Well, I appreciate this question coming in because this is a question that I had to get answered personally for myself. Being a wood construction guy, I hadn't really dealt with drywall a whole lot, but type X is a fire rated drywall. It is designed to meet the 1 hour requirements, and it was kind of originally what was used to meet the fire requirements. And then type C was developed, and it has a longer rating that it can last. So type X was kind of the beginning, and type C got to be where a more advanced drywall product is used. So there's different inhibitors in type C than there is type X, but they both can be used, but just be sure to check the specifications.
Okay, thank you, Kyle. You mentioned on one of your slides that the IBC, the International Building Code, allows for taller buildings made of wood. How tall can you go?
In type 4A construction, you can go up to 18 stories. Type 4B, you can go up to 12 stories. And type 4C, you can go up to 9 stories. I would also like to recommend one of our sisters or people we work with a lot is Woodworks, and they have a lot of information on mass timber buildings, which get into type 4 construction a lot. So you can visit Woodworks and get more information if needed.
Okay, thank you. Yeah, that's a good shout out to Woodworks, or sister organization that does a lot in this work. So I appreciate that. You went through a lot of details today, so just a real lot of information. Is there a place where we can download these details, Kyle?
Well, yes, there is a lot of information in this publication, and I just touched on some of it. So number one, reference this publication, but the details you see here are on our website. If you have signed up for our designer circle, you have access to all these and more details that are available to be downloaded into your design plans. So I would definitely recommend looking on our website for these details, not only these details, but there are many more there that are available for use.
Okay, thank you, Kyle. When using the rim boards, is it always necessary to use gypsum on the side of the rim board?
Well, as I stated in the presentation, it's going to depend on the assembly itself. If the ceiling wall is able to protect it, then you do not have to protect the rim board assembly, but there are different assemblies shown. So each detail is going to have to be provided, but not necessarily do you have to have drywall attached to the rim board itself.
Okay, thank you, Kyle. It looks like we're coming up on our hour that we had allocated for this thing. We do have a couple housekeeping things I want to get through. If there's some questions out there on our site, we will have our engineered field staff reaching out to you with responses to those questions. So you will get your questions addressed. I just wanted to let you know. But thanks again, and use the QR code, to review our survey. But there's a few things I'd like to touch on before we leave. The first being to make sure the APA update newsletter. Make sure you signed up to receive our APA newsletter so that you'll be notified of our future webinars and updates to APA publications and standards. We will be having a webinar coming up in July, and you want to make sure you get notification of that when it comes out. So please sign up for that newsletter. To receive it, all you need to do is from our homepage is to click on sign in the upper right hand corner of the page, as shown on this slide here. In the drop-down menu, you simply select register. Then you'll need to let us know what you'd like to receive from APA. In this case, you request the APA update newsletter. Lastly, I'd like to mention that APA has field staff located throughout the country. These talented people are available to assist design professionals, builders, and code officials. Their individual contact information can be found on our APA website, www.apawood.org. Please feel free to reach out with them and take advantage of this free resource regarding this topic or any topic related to APA member products. And again, don't forget to download your AIA or ICC certificate of completion from the links in the follow-up email that will be sent to you in about an hour. And with that, I'd like to thank you for attending and have a great day.